Hi, everybody. Welcome to Mr. Hayes' World of Math. I'm Mr. Hayes, my world of math. We are going to help you guys learn how to do rational equations right now. And I've got it down to about a 6-step process. Pretty straightforward, pretty easy, and I think it's also going to help you understand why we're doing what we're doing. To just jump right in. So the first step over here is find your horizontal asymptote. And you're going to take your highest degree term in the top and divide it through by your highest degree term on the bottom. So numerator and denominator. What does that look like? It looks like this. So I would take, so for my horizontal asymptote, I'm going to take x squared is my biggest term in the front, in the top, in the numerator, and my denominator has a highest degree term of 2x squared, negative squared there. That is going to end up equaling 1/2 when I reduce that. So that is going to be my horizontal asymptote. We'll talk later about what happens if the degrees are different. So I haven't forgotten about that. But then we're going to come through and we're going to draw a very nice horizontal asymptote at y equals 1/2. Now, the next thing you're going to do is we're going to factor the equation. We are going to find the domain, and I'll explain why that's important here in a second. And then we're going to reduce the equation if we can. Now, the reason why the domain is important is because the domain is going to help us with the next 2 steps. So let's go over here. The top is going to factor into x plus 5, x minus 5. The bottom divides, you can divide a 2 out of it, and then whatever's left over, you're going to get x plus 2 and x plus 5. Now, before you cross off the x plus 5s, we're going to get there. I'm just going to make a note over here that for my domain, x can't equal -2, and x can't equal -5. Both of those numbers don't work because it's going to make this original equation equal to 0 in the denominator, and that's not allowed. So then from there, we're going to go ahead and divide these out. And then I'm going to go ahead and write down the simplified version. Y equals x minus 5 over 2 times x plus 2. Why did I say find the domain? Here's why. Because in step 3, we are going to try to find, you're going to find any holes. Now, I put holes in quote because it's technically a removable discontinuity. Discontinuity is places where you have to pick up your pen when you're drawing the graph. And it's removable because we removed it. It's not, you're going to see the vertical asymptotes that are very, they make their presence known. Holes, not so much. And so you're going to get this from the domain issue that divided out. Okay, so the domain issue that divided out, so that is going to be that x minus 5. So we're going to have a hole at x equals -5. Now we need to figure out what y is going to equal, and we're going to plug that -5 back into the original equation. Or not the original equation, I'm sorry, the simplified equation. So I'm going to get -5 minus 5 over 2 times -5 plus 2. And so then that's going to get me a -10 on the top and a -6 on the bottom. So I'm going to have a hole at -5, comma, and that's going to be 1 2/3. So that's going to be approximately here. Now again, we're going for a really good estimate. We're not going for perfection. So I would be fine if it's between 1 and 2. Your teacher may vary. Now, why again? So I'm picking this number here because this is the number that divided out. Okay, so that's the part of the domain that divided out. So it's not, when we draw this, you're going to see a graph that looks like this. And it's going to look like just a regular graph, but we jump that little spot there. Now the other one that doesn't divide out is you're going to have a vertical asymptote. And if you have more than one that divides out, you can have more than one hole. If you have more than one domain issue that doesn't divide out, you're going to have more than one vertical asymptote. Oops. So that means I'm going to have a vertical asymptote at x equals -2. And again, this is coming from here. And that's the domain issue that's not dividing out. So that means I'm going to draw a very nice line here at x equals -2. That's a little Seattle Seahawk alternate jersey there. And then the last part you're going to do, well, this last part, 5 and 6 are kind of together, is you're going to find points to the left and to the right of each vertical asymptote. Because those are going to be the parts that a lot of the action happens, and that's going to be the most extreme version of what happens of each vertical asymptote. So in our case here, we only have the one. Now, I usually do 2 to 3 points on each side, so I'm going to do the first 2. I have a vertical asymptote at 2. I will usually put the little y value as VA, so I don't think about doing that, having to solve it out or not worrying about it. And then I'm going to go 2 to the left, so I'm going to go -3 and -4, and then I'm going to go 0, or excuse me, -1 and 0. So then I'm going to go -1 and 0. And then I'm going to plug these into the simplified version just because it makes life a little bit easier. So if I plug in a 0, I'm going to get a -5 over 4. So at 0 and 1.25, -1.25, I'm going to be there. If I plug in a -1, I'm going to get a -6 over 2. So that's going to be -6 over 2. So that's going to be what, -3 then. Go down here. So then on this side over here, and that's going to be actually points. So, and actually I'm going to kind of combine 5 and 6 here. So let's say sketch curve. That might be better than graphing. Sketch the curve. So that means that I'm going to get infinitely close to the vertical asymptote, come up through here, and go through this way. So a couple of things here. Remember, like, if I were to plug in a really large x number into the original equation, it's going to get really close to 1/2 is what's going on. And so the same thing is going to happen this way. If I were to plug in a very large negative number, so let's say like a -10,000, it's going to be very close to 1/2. So that's how that works. And then the -3 I plug in, I'm going to get -8 over 2. So that's going to be -8 over -2. So that's going to be a +4. 2, 4. Interesting note, notice how this one's -3.5 below the asymptote. This one's 3.5 above the asymptote. If you have a single asymptote, that's generally going to be the case. And then for -4, if I plug that in here, I'm going to get a -9 over -4. So that's going to be 2.25. So that's going to be right about there. And then the whole I can actually use as another estimate as well. And there's the rational graph. Now, I promised you I was going to talk about the horizontal asymptotes, and that's what I'm going to do down here in this little box down here. I'm going to go ahead and zoom in for sake of case. I'm sorry, I need to probably rework this. Potential horizontal asymptote possibilities. It's kind of redundant. I'm sorry about that. Okay, so the first thing is you're going to have a low degree over a high degree. So as an example, I might have x over x squared. So that's going to equal 1 over x. So as x gets larger and larger and larger, 1 divided by 1,000, 1 divided by 1,000,000, one is going to get closer and closer to 0. So you're going to have a horizontal asymptote So you're going to have a horizontal asymptote at y equals 0. You might have something where you have the same degree. So I would get, let's say, like x squared over x squared. That simplifies down to 1. Whatever, so it's going to be y equals the simplified number. So if it's 1/2, like our case, it's going to be 1/2. If it's 5, it's going to be 5. And then if I have a higher degree over a lower degree, for example, let's say I have 2x squared over x. So then that would simplify down to 2x. That's something called an oblique or slant asymptote, depending upon book or teacher. And that's something for a different time. We tend to focus more on that in our pre-calculus course. Effectively, it is a line, just so you know. So if this is my graph, let's say I have a vertical asymptote like this. You would actually divide, usually through synthetic division, but you would actually go through and divide the rational out. And in this case here, you would end up having a line like that would actually, in this case, have a slope of 2 because that's the coefficient in front of the x. And then from there, you might have so when you plot your points, you might get something that looks like this. Okay, so depending upon the course, that may or may not be something that you're covering right now. So I would talk with the teacher about that. So that being said, if you want more information, I've got videos here and here that goes more in depth in terms of the process this. I believe one of them is even about obliques, so hopefully you'll find that helpful. So we'll see you next time. Bye.